Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay. Good afternoon, everyone. How are you today?
Sir.
Fine?
Fine, sir.
Okay, thank you. So, as usual, before we start our lesson, let's pray. Pray begin. Amin. So, please fill the attendance. You know the place of the attendance in the group description, so you can see your groups. Please fill the attendance now. Only 7 students. Where's the others? Let's wait for them. All right. Now it is 9 students. Okay, let's start the lesson. Okay, don't wait for the others. Okay. Did you see my screen, guys?
Blurry.
In the screen?
Blurry. Blur.
You see my screen, right?
Yes,
Blurry, sir.
but it's blurry.
Chemistry lesson 13. Okay, you see, right? Or you cannot see?
Bisa lihat tapi agak buram, Pak.
Blurry.
If this buram, it's because of the connection, I think. But can you read it? Chemistry lesson 13.
Yes, sir.
Okay.
Yes, sir.
And can I turn off my cam, sir?
Yeah, okay. You can turn off your camera if you cannot see the slide. Okay, so this is chemistry lesson 13, August 13, 2020. So what we're going to see today, we're going to see the history of the atom now. Yeah, after we learn about the atom and its structure, yeah, its basic structure of the atoms. Now in this lesson, we're going to see the history of the atoms. Okay, so after this lesson, I hope all of you will know the history of the atoms and the invention of the subatomic particle, including proton, electron, and neutron. This is what we're going to see today. Okay, let's start with the first one. So this is, we know that we learn about these things before. Yeah, we learn about the what the name of the atom is coming from the Greek language, from the Greece. It is called as an atomos. Anyone remember what is atomos mean?
Cannot be separated.
Very small. Very small.
It cannot be
Separated.
separated. Cannot be divided, right? I lost my screen, I think.
Yes, sir. It's all white.
Okay. Something happened with my screen. I think I lost my screen. Okay. So I have to go back to the Sorry about this. So I have to use my Google slide then. Okay. Okay, so it is coming from the word atomos, from the Greek what philosopher, it's mean indivisible, right? Atomos mean indivisible. And after that, atomic theory start to be what research. So some scientists start to research about the atoms after he know that there is a smallest particle in the matter. It is called as the atom, which cannot be divided into a smaller again. So after that, the scientists start to research about the atom, and the first scientist that make the theory about the atoms called as John Dalton. He made one theory in 1803 called as John Dalton's atomic theory. What he said about the atoms, this is the simplest atomic theory according to the John Dalton's. He said that all matter is made of atoms. Yeah, all the matter is made from the atoms. All atoms of given element are identical. So if there is an element, the atoms inside the element are identical. Identical means it's the same. So if we have oxygen element, so the atoms in oxygen element are identical to each other. And then the atom of one element are different from other elements. Yeah, the atoms of the elements which are different also will be different. So for example, if we have oxygen and hydrogen, yeah, so the atom will be different. Atoms combine in whole ratios to make compounds. So we can see that, for example, in the formation of the water, water compound. So there are two types of atoms, hydrogen and oxygen. We know that the composition of the atoms in a compound, it must be fixed proportion. So we have two hydrogen and one oxygen. Yeah, we have two hydrogen and one oxygen. So this is called as a fixed ratio. Later on, we're going to learn about this law. We call this one as a law of constant composition. Yeah. Later on, we're going to see this law of constant composition. Okay. In a chemical reaction, atoms are separated, combined, or rearranged. So in a chemical reaction, actually, atoms are not destroyed. Atom is not go anywhere. It's just changing. It's just separating from one atom to another atom, or it's combining from one atom to another atom, or it is rearranged. It's already there is a combination. It's just the rearrangement of the atoms. So the atom will not go anywhere if there is a chemical reaction. And then we learn about this. Actually, I don't want to talk much about this, about the electron, proton, and neutron. Last lesson, we learned about this subatomic particle. What is electron, proton, and neutron? What is the charge of those? And what is the position of the subatomic particle in the atoms? Actually, today we are going to learn only the history, how the electron, proton, and neutron are invented. So we're going to see the first one, how the electron are invented. After we know the after we know the first atomic theory stated by Dalton, and then after that, scientists start to research about what is inside the atoms. At that time, he don't know about the proton, he don't know about the electron, he don't know about the neutron. He just know about there is an atom which is very small, and it is the smallest particle. As you can see here, Dalton didn't say anything about proton, neutron, or electron. At that time, he didn't know about the proton, electron, and neutron. So the first thing that is found is electron. So rather than proton and neutron, the first subatomic particle which is invented is electron. It is invented by a scientist called J.J. Thomson in around 119. At this time, J.J. Thomson made one experiment called as a cathode ray experiment. So this is called as a cathode ray experiment. It is using a tube. Yeah, cathode ray experiment is using a tube. This is the tube that it is using. Yeah, the tube that is used here. Yeah, and then there is an electrical source in the tube here. Electrical source in the tube. Yeah, there is positively charged and negatively charged. Yeah, they are connected to the source of electrical. And what happened when the source of electricity is turned on? There will be a beam of light is coming from the negatively charged to the positively charged. A beam of light is coming from here to here, from negative to the positive. So we understood that this beam of light is containing a negatively charged particle. Yeah. And later on, this negatively charged particle are called as corpuscle, but later on it's named as an electron. Yeah, so it is a beam or a rays that move away from negative to the positive. I have a video about this. Okay, this is the video. Let's watch. Sorry, the internet connection is...
To demonstrate a Crookes tube, a cathode ray tube, we need a high voltage power source, such as this one. We need the Crookes tube, which has a metal cathode, a metal anode, a screen that has been coated with a phosphorescent material that gives off light when struck by electrons, and a bar magnet. As we turn on the screen, we notice that electrons are emitted from the cathode, and as they strike the fluorescent screen, we're able to see the cathode ray, this stream of electrons illuminated. We can use a magnet to show the deflection of that stream.
Here we can see the electrons being deflected by the magnet. The cathode ray moves upward. If we reverse the magnet, we would predict that the beam would be deflected in the opposite direction. And we observe that the beam is deflected downward.
Okay, as you can see here, he used a magnet to show that there is a particle there. So when the magnet is in one side of the magnet is given, what happened? The beam are going to up. But when the magnet are turned around in opposite side, the beam are going down. So from that's when he understood that there are particles there in the beam, and because the particle is coming from negatively charged plate to the positively charged plate, so that's particle are negatively charged particle, and then later on that negatively charged particle are called as the electron. Okay. Okay. Let's move to another one. Okay, another experiment that important also in the invention of electron is done by Robert Millikan. Robert Millikan, now he continued the experiment done by J.J. Thomson. J.J. Thomson found the electron, and then after that, Robert Millikan, with his experiment called as the oil drop experiment or Millikan oil drop experiment, he found the mass and the charge of the electron. Yeah, after the electron is found, and then Robert Millikan can calculate the mass and the charge of the electron. How he calculated? Now there is also a video about the experiment that Millikan did.
In 1909, Robert Millikan, working at the University of Chicago, succeeded in measuring the charge on the electron. He allowed a fine spray of oil to settle through a hole into a chamber where he could observe their fall. The top and bottom of the chamber consisted of electrically charged plates. He introduced a source of X-rays which can cause creation of charges when they strike matter. Charges produced by the X-rays attach to an oil droplet, producing one or more charges on the droplet. When there is no voltage applied, the fall of the droplets is determined by their mass and the viscosity of air through which they fall. When a voltage is applied, the droplets that have a negative charge will fall more slowly, stop falling, or even rise, depending on the number of charges on them. By adjusting the applied voltage and observing the droplets both with voltage off and voltage on, Millikan was able to determine that the charges on the droplets were all multiples of a smallest value, 1.6 times 10 to the minus 9.
Okay, so from this experiment, Millikan start to observe the behavior of the oil drop when the voltage is on and when the voltage is off. When the voltage is off, only the mass is playing in the experiment, right? Because there is no charge. Okay, so the oil will drop because of the gravitational force. It will going down. But when the voltage is turned on, what happens? Some of the oil drop is not going down. It's getting slower going down. Even some of the particle of the oil drop is going up. Yeah? So by comparing this behavior of the oil drop when the voltage is on and the voltage is on, then Millikan can calculate the charge of the electron or the negatively charged particle, and he found that the charge of the electron will be 1.6 times 10 to the power minus 19 coulomb. And after that, he also can find the mass of the electron. Okay, so invention of electron, two guys are important. J.J. Thomson as the one who found the electron, and Millikan the one who found the mass and the charge of the electron. Okay, after the invention of the electron, then J.J. Thomson made its own theories. So this is the second theories. The first theory is made by the Dalton. Yeah, we see it before. Now the second theory, it is Thomson theory. Thomson theory is a little bit advanced if we compare with the Dalton. Dalton didn't say anything about the subatomic particle. He said only about the atom itself. But now Thomson is a little bit more advanced. Now Thomson is talking about the electron, the one that he found already. He said that an atom is actually a spherical cloud of positive charge. This spherical cloud is the blue one, and this blue one is positively charged. Yeah, but he don't know what is the name that positively charged because the proton at that time hasn't invented yet. So he just know that there is a spherical cloud of positively charged particle. Yeah, and then in that spherical cloud, it is distributed a negatively charged particle, which is called as an electron. So electrons are spread out. Distribution of electrons are distributed in the spherical cloud, is spreading in the spherical cloud of positive charge, and the total charge of this particle will be neutral. Okay, the total charge of this atom will be neutral because the blue one are positive, and this thing which is spread like a plum pudding here, it is a negatively charged, which is electron. So there are positively charged actually, but at that time Thomson didn't know the name of that positively charged because the proton hasn't been invented yet. Okay, after the invention of the electron by Thomson, and then another scientist made another experiment. It's called as a gold foil experiment. It's done by Ernest Rutherford. This gold foil experiment is telling you about the existence of the nucleus. Yeah, we know that in the atom there is a place in the center yeah, in the center of the atom, which is very small. That place is called as the nucleus. Later on, we know that at the nucleus there is proton. There are proton, not there is. There are proton in the nucleus and also neutron. Yeah, but at that time we don't know about that one. We don't know about the proton and we don't know about the neutron. We just know about the electron. So this scientist Ernest Rutherford found the place first, which is called as the nucleus. How he found? He made one experiment called as a gold foil experiment. He used a beam or rays of alpha particle. Yeah, he shoot the alpha particle to the thin metal foil. This is the thin metal foil. Generally, actually, he used the gold foil. So the name of experiment, gold foil experiment. As you can see from the color, it's a gold color. So what happened to this alpha particle when it is salted to the gold? When it's salted to the gold, most of the alpha particle are going through the gold foil. Some of them are deflected atau dibelokkan. Some of them are deflected, and some of them is also reflected. So, do you understand why it is reflected? What do you think? What happened to this one? Why it is reflected? Why the beam are reflected? Because it is
There are hole in the atom or jarak itu, ada jarak kecil.
no, I mean the reflected, dipantulkan. Why it is reflected? Because maybe this ray is what crossing some of the thing here, crossing something in the inside this gold foil, isn't it? When it's cross something, it is reflected. Cross, reflected. Is it possible like that?
Yes, sir.
Yes, yeah. Maybe there is something here in the gold foil that crossed by this particle. So this crossing made, or this collision made the particle are reflected. Ya, ada sesuatu partikel, mungkin sinarnya ini menabrak sesuatu itu sehingga dipantulkan. Ya, so we're going to see what happened actually in this video. In the video, okay, I have the video so of this one. Let's see.
In 1910, Rutherford and his co-workers were studying the angles at which alpha particles were scattered as they passed through a thin gold foil. Most of the alpha particles passed through undeflected. However, a few were found to be scattered at large angles, some even back in the direction from which they had come. This meant that they had collided with an object much more massive than the alpha particles themselves, yet so small that only a few alpha particles encountered them. This atomic level view shows what is happening. Most of the atom is occupied by the low mass electrons. The nucleus is small and massive. When an alpha particle encounters a nucleus, it is scattered at a large angle.
You see something there that make the rays are reflected? Did you see? Okay, let's watch again what we see here. Okay, if I could pause it, maybe we can see. Okay, can I pause it? Yes, now it is paused. As you can see here, there is something here, right, in the center of this particle. What do you think? What's the name of this?
Nucleus.
Yes, this is the nucleus. So that's why Rutherford is actually found the nucleus. Okay, Rutherford is actually find the nucleus. he said that there must be a very small positive central core, it's called as a nucleus, and the rest of the atom, 99.1999%, is empty space. So this small particle in the middle, not particle, sorry, small place, small core in the middle is called as a nucleus. But at that time, he didn't say about the name of that positively core. Yeah, it is contained of what? He didn't know that that positive charge is the proton. At that time, protons are not invented yet. Okay, he just know that there is a place in the middle where it is a very positive and very small. It is positively charged, and it is called as a nucleus. Yeah, so Rutherford found that one. So that's why Rutherford tried to sketch his own theory about the atoms. What he sketched, is seen. Rutherford sketched the atom like this. So in the middle there is a positively charged. It is the middle called as a nucleus. It's contained positively charged, and this electron is already found. Is negatively charged. Is rotating around the nucleus. Okay. But at that time, he didn't know that this positive particle is called the proton. Who found the proton? Later on, we see that the proton is actually found by the scientist named Agent Goldstein. So before that one, it is a different experiment. Yeah, Agent Goldstein actually he found already a positively charged rays, which is opposite the negatively charged rays. Before J.J. Thomson, remember J.J. Thomson? J.J. Thomson found the negatively charged rays. It is called as a cathode rays, isn't it? Cathode rays before the experiment before here. In this experiment, yeah, this is cathode rays, the rays that coming from the negatively charged or the positively charged. Actually, these cathode rays have the opposite rays. Yeah, this cathode rays is sinar kathoda. It is the sinar kathoda. Now it's going to the left. It has the opposite rays. Yeah, it has the opposite rays. It is called as a canal rays, and this canal rays is positively charged rays. If the cathode rays is negatively charged, canal rays is positively charged. This canal rays later on is called as the proton, which is located in the nucleus. That's rays that make this nucleus is positively charged. Yeah. But actually in the nucleus, there is not only protons, there are also another subatomic particle. Yeah. How do you understand that one? Those another subatomic particle is called as a neutron. It is found later by James Chadwick. It is the last subatomic particle which is found in 1932. James Chadwick made this experiment. The sketch of the experiment is like this. He solved alpha particle, again like gold point experiment. He solved alpha particle, and then there are some radiation are coming out after the alpha particle are sorted in the beryllium. Now it's beryllium foil here. Some of the unknown rays are coming out, and then after that he put paraffin wax. Paraffin wax is a substance that contain many proton. Yeah, this is contain of rich proton substance. It's many proton in here. What happened when these unknown rays touch this paraffin wax? The proton are kicked out from this paraffin wax. Yeah, the proton are kicked out. Protonnya tertendang with this rays. And he understood that if these rays can replace the proton, so this rays must be look like the proton. So this rays look like the proton. That's why neutron is actually has the mass equal to the proton or similar to the proton. The mass of the neutron is similar to the proton. But how do you know the charge? Because there is no attraction and no repulsion here. Tidak ada tarik-menarik dan tolak-menolak between this unknown particle with this proton. So this unknown particle is seen to be neutral. That's why this neutral charged particle are different from the proton and different from the electron. So this is a new particle and it is called as a neutron. Yeah. Okay, after proton and neutron found, now it is complete. Electron already found by J.J. Thomson, and then proton is already found by the Agent Galstein. Nucleus itself is found by Rutherford, and then the last one, neutron, is found by James Chadwick. Now it is already complete. All these subatomic particles are already found or invented. But after that, there is something still remain a problem. What is the problem? The problem is, how about the electron? How is the movement of the electron? Because electron is moving around the nucleus. How it is moved? So this remains as a problem. So this problem are answered by the scientist named Bohr's, and he made one model. It's called as a Bohr's models. Bohr's model is like this. He know already there's a nucleus in the middle, and its nucleus is containing proton and neutron. Proton and neutron is the nucleus, yeah, positively charged and neutral charged, and the electron are moving around the nucleus. Okay, but how the electron are moving? Both say that the electron are moving in orbitals. What is orbital? Orbital is a pit, ways where the electron are moving. It's like the Earth. Earth has a orbit, right? Earth are rotating around the sun, and it has an orbit, right? Like any other planets, Earth also has an orbit, and the other planet also has an orbit. It's our fate in rotating the sun. The similar thing in electron here, both say that the electron also moving in its own fate, or it's called as an orbit, right? So that's why the electron cannot move in the different movement, yeah, or in a random movement. No, it is moving in its own fate, is called as an orbit. Okay, as you can see here, two electrons are moving in this orbit, another electron are moving in this orbit, but it is different from the Earth. When we say about the orbit of the Earth cannot move in different orbit. Earth only can move in its own orbit, yeah. Earth cannot go to the Mercurius orbit or to the Mars orbit, no, cannot. Earth only can move in its own orbit. But in the electron can move into one orbit to another orbit. Yeah, the movement of this electron needs an energy. So some of the energy can be released, or some of the energy can be absorbed by the electron. So when the electron absorb or release an energy, it can change its orbit. It can change the place where they are moving, the path where are they moving. So it's different from the orbit of the Earth, which cannot be changing, but the orbit of the electron can change. So electron can jump from one orbit to another orbit. Okay. And this Bohr's atomic model then revised by the next model of electron. This is the model that is still used up to now. This is called as the modern atomic models. It is still valid, and it is the last model that we use up to now. This is also actually the revision of the Bohr's atomic models. It looks like Bohr's atomic model, as you can see here from the picture. There is also a nucleus, and there are proton and neutron in the nucleus, and there are also electrons are moving around. But the difference here is who made this theory. Actually, there are many scientists who are working in this theory. One of them is Schrödinger, is talking about the clouds of the electron. Yeah, the cloud of the electron. It's didn't say about the orbit of the electron, but it's saying about the cloud of the electron. As you can see here, the brown color is the cloud of this electron. Another brown cloud here is the cloud of the electron. So instead of the orbit in the cloud model or atomic modern atomic model, there is a cloud of electron where the probability to find the electron are very big at that cloud of electron. Okay. So we have only 3 minutes, so I'm going to stop here because I don't want to proceed to the Dalton atomic theory weaknesses. But the weakness of the theory in next meeting we are going to see. So I'm going to review what we see from the beginning. Let's see. Actually, what we see today from the beginning, we see first the atomic theory, okay, then the history of the atom. So the first one is Dalton atomic theory with its theory. Yeah, it's very simple. There is no proton, neutron, and electron. This is the simplest one. And then after that, Thomson found the electron by his experiment, cathode rays tube experiment, and then Millikan found the mass and the charge of the electron. And after that, Thomson made his own models, his plum pudding model, like this. Positively charged particles are sprayed, negatively charged particles sprayed in the positively charged particle. And then after that, Ernest Rutherford found the nucleus, yeah, where the positively charged are placed. And then we understood that that positively charged is called as a proton. And then after that, neutrons are found by the James Chadwick. And after that, Bohr's model coming. Bohr's model is talking about the movement of the electron in its orbit. Yeah. And this model later on revised by the modern atomic theory called as a cloud models. Okay, so this is the model that's still used up to now. Okay, some of you are writing in the chat. Yes, that's Schrödinger box theory is the same, yeah, with this one. Maybe you learn about this one in physics. So they are the same things. Okay, they are the same thing. That the one that you learn in physics actually is the same. I'm just explaining here in the chemical sides of this experiment. Maybe you will learn also the physical physics sides of this one, but they are the same things. Schrödinger is about the probability, about the cat, what cat in the box is talking about the probability of finding the electron. Later we're going to see about this one also. Okay, but now it's enough for today. We learn about the history now. After this one, we have the weaknesses of each model. So we have a different model. We have Dalton, Thomson, Rutherford, Bohr's, and then the last one, modern atomic models. We're going to see what are those model weaknesses in the next lesson, inshallah. For today, that's enough. After this, we are going to have the unit test, the post test at 3:30. So be ready for the post test. For the unit test, I'm going to make an announcement in the groups, okay, about the unit test. Thank you. See you next lesson. Assalamualaikum warahmatullahi wabarakatuh.